Part 6 in Module 7 is devoted to the program evaluation and review technique and the critical path method, often known as PERT and CPM. After a very brief introduction, we're going to use a simple example to demonstrate what the critical path is, but we're not going to go through the mechanics or the methodology for computing the critical path. We just want you to understand what it is. We're going to use the same example to illustrate PERT, Program Evaluation and Review Technique. We want to show you how to go about shortening up a project if you need to, or sometimes it's called crashing a project. And finally, we're just going to illustrate Gantt charts. Probably most of you have seen or used Gantt charts before, but want to show that they can also include the critical path on them. If a project has a deadline, or if there's some urgency in getting it done as fast as possible, it's really important to know what the critical path is. The critical path activities are those activities in the project which, if delayed, would delay the completion of the whole project. That is, these are the activities that have no wiggle room. So you need to know what the critical path is, so you know what to manage with the most effort. If you want to shorten a project, then you have to shorten one of the critical path activities. This practice is called crashing the project. You can shorten the critical path activities in a very expensive way, or you can do it in an economical way, and this is what PERT is all about. We're going to use an example of you getting up, getting ready for work, to illustrate the critical path method and the PERT technique. So you have to have a list of what the items are, the activities that are involved with the project. So here's a list that's been put together, and this list isn't in any particular order, and it doesn't have any other information at this point, but this is the list of the activities that need to be completed in order for the project to get finished. Once we have the list of activities, we can get estimates about how long they'll take to complete. So that's the next step, get the activity times. Suppose you wanted to know how long it would take to get ready for work with the list we already have. If you just did everything in a nice linear fashion, you could just add up those times and you get 78 minutes. But in reality, some things can be done in parallel, two things happening at once. You need to know what those items are, and so you need to know what the precedence is of items so that you know when things can start and end. A precedence chart shows for each activity what activities have to be completed before they can begin. And so this shows for each item which items have to be completed before it can start. So for our example here, you'll notice that you can start making coffee anytime after brushing your teeth. That is, the coffee can be brewing while you're taking a shower. They can be in parallel. You can start drinking coffee anytime after the shower and in parallel with a number of other activities. You must dress before you eat breakfast, but you must be finished with breakfast and coffee before kissing your spouse goodbye. Once we have a precedence chart, we can begin to build an arrow diagram showing the items and acknowledging what the precedences are. This arrow diagram is used to calculate the critical path, but we're not going to do that here. But suppose the coffee maker is prepared after brushing your teeth, then coffee can be brewing during the shower. So we would start out our diagram with a path with brushing your teeth and then preparing the coffee maker. And those two things together take 6 minutes. Now the coffee can be brewing during the shower. Once the coffee maker is prepared, we have two paths, B and C, that can operate in parallel. The shower can take place, then grooming activities, and then getting dressed and eating breakfast. that string of activities can begin. Also, path C can start at the same time. The coffee can brew, and then when the coffee's done, it can be consumed. Path B takes 45 minutes, path C takes 25 minutes, and they both have to be done before we can do the final path, which is path D, kiss your spouse goodbye and leave for work. So our new duration time would have a minimum time of the time for path A, which is 6 minutes, and then the longest of B and C, which is 45 minutes, the shower path, and then finally path D. So if you add those times up, we now have a 53-minute duration. That's 25 minutes less than the original 78 minutes. So the time that it takes to get ready for work will be 53 minutes as long as the activities on paths A, B, and D are not delayed. So these are the critical path activities. So path C, making and drinking the coffee, is not on the critical path. And actually, drinking the coffee could be done at any number of times and still be finished and not disturb the critical path. Here's another example of a project with a lot of activities. The activities are shown on the arrows with how many days it takes for each activity. And if you were to look at all the possible paths through this network, you would find that the longest time is 54 days. So that's the duration that's shown on the right. The activities that are on that path, the 54-day path, are the critical path activities. If you look at any other path through the network, they're all less than 54 days. So if any of the activities on the blue line are delayed, the project will be delayed. So that's why they're the critical path activities. So it's real important if you're the manager, if you're a project manager, if you're going to monitor anything, it's going to be those critical path activities. Getting back to our getting ready for work example, if you note that the starting time for the activities on path C are not critical, they just have to be done within the 45 minutes that parallel the critical path, then they can be delayed by as much as 20 minutes without delaying the departure time. This flexible time is called slack time. We use slack time to give us the flexibility for scheduling resources within a project so that we can stay on track and make sure that we're not in trouble with the critical path activities. Crashing the project is an expression used with the PERT and CPM techniques for reducing the duration of the project by shortening some of the critical path activities. So normally what we would do, for example, if we wanted to reduce the time to get ready for work from 53 minutes to 45 minutes, we would examine the critical path activities to see where we could take out 8 minutes with the least amount of cost or anguish. If we were crashing a project where we were paying by the hour or by the minute, then we would look at the cost to reduce a minute from each item on our critical path and then make an economic decision as to how to cut down on the duration at the least cost. The last topic in this part is Gantt charts. Gantt charts are visual scheduling tools, sometimes called step charts. They can also graphically represent PERT CPM chart. They show dependencies between tasks, people, and other resources, and they're useful for tracking where you're at and showing where the project is ahead or behind. To construct a Gantt chart, we start by listing our activities in chronological order from top to bottom on the vertical axis, and we can include our milestones and toll gates in the list. And then across the horizontal axis we put our time frame, whether it's days or weeks or months. Then typically we use bars or boxes to represent the activities, starting with where they begin and then finishing where they're anticipated on ending. So they represent the duration of the activity. Milestones are typically put in with diamonds. In this illustration, we see a milestone shown right in the body of the Gantt chart. But I think the more common convention is a vertical line at the milestone and the milestone actually at the top of the chart. Typically on a Gantt chart you would also show the dependencies between activities with arrows or lines connecting where one activity ends and another one begins. Here we see an example of a Gantt chart. It has time in quarters of a year across the top, and it shows the activities down the left with milestones every so often. And if you have the opportunity to read the different items, you can see that they've got a fairly detailed step-by-step approach figured out in order to accomplish this project. Very often Gantt charts will indicate who's responsible for overseeing a particular task. It can be either written in the bar or it can be a column next to the activities, or you can have an accountability matrix like you see here, where the people are shown across one axis of the matrix and the activities are across the other axis. This would be good if there's multiple responsibilities that people might have for a project. This graph is an attempt to illustrate that it's unrealistic to expect that progress on a project will be done in a linear fashion, a uniform fashion throughout the project. This is called the standard S-curve, and it's trying to illustrate that for most projects you're going to have about 3 phases, and you can plan these into your project, into your Gantt chart. The first point is that early stage, in the getting started part, you might spend a little time getting up to speed, so in the first third you might only make about 1/4 of your progress. Then in the middle stage you go a little faster, you catch up and get a little bit ahead, so that about 2/3 of the way through the project you've got about 3/4 of it done. Because typically at the end you're going to find some loose ends and some things that are going to take a little longer than you expected in order to finish on time. So sometimes this is loosely called a learning curve because there's a lot of parallels with it. But something to consider when you're planning, that you don't load the work in a manner that isn't realistic. This is an illustration to show poor planning, where you leave most of the work at the end of the project. As an academic, I would say that the red curve fairly accurately describes the way most students get their term papers and projects done in a university.